Okay, section 1.3, segments, rays, and angles. There's a lot of info in this section, so I will try to make it as quick as I can. A lot going on. So a line segment, so if we say a line has no end, okay? But a line segment has two distinct endpoints, so that's kind of important on that. Oops, two distinct endpoints. So when you have a line segment, you might have line segment AB. Okay, the notation for a line segment then, again, these are capital block letters. It doesn't matter what order. It doesn't matter A, B, or B, A. Those are the endpoints, distinct endpoints A and B. Okay. If there's something in between, you do not need to use 3 letters. Okay. If I have another line segment, okay, that is just line segment DF or FB. You do not need to put the E in there. You use the endpoints only. There could be lots of points in between that are labeled. There are infinitely many points in between. It's just what's labeled and what's not. Okay. There's the segment addition postulate. Okay. Or adding segments. A, B, and C are 3 points on the same line with B between A and C. As soon as I use that word between, things are linear. Okay, it's in a straight line. So we've got a line. Now between just means somewhere in between. It doesn't have to be right smack dab in the middle. It doesn't have to be equidistant. Okay. So then the length. So notice none of these have lines over the top. It's just A, C, A, B. If you have line segment A, B, that's the thing. If without the line over the top, that's the measure of line segment A, B. So that's really a number. Okay. So what they're saying in here is then that for this whole thing, that length is going to equal this length AB plus BC. Okay, so is let's put it in nice little terms. This is it's piece plus piece equals whole thing. There's no overlap in my orange piece and my blue piece. They connect. So segment addition postulate is, in simple words, piece plus piece equals whole thing. Okay. If we have the whole thing and take away the same piece, it's going to be equal. Okay. So just a couple examples. You might actually have the numbers here. Okay. Find XZ. No line over it. That means find how long. What's the measure of X is Z? That's the whole thing. Well, that just means doing a little bit of fraction arithmetic. We're going to have to do 4 5/8 plus 2 1/2. However you get that job done at this point is up to you. 1/2 is 4/8. That means it's 6 9/8. Well, we can't leave it that way, so it's 7 1/8 inches. If you were given information in fractions and or mixed numbers, that's how you should answer it as well. Okay, keep it in the same format as it's given to you, unless it tells you otherwise. Okay, and in the same fashion here, we've got collinear points. They're telling us a bunch of information here. GK is 24. That's the whole thing. The whole thing is 24. HJ is 10. So from here to here is 10. Different colors are so helpful with geometry. If you're doing things on paper, get some colored pencils out or something. I cannot tell you how much that helps. GH, HI, and IJ are all the same. So whatever these are, they're all the same. Well, from segment addition, if we just look at the HJ, the blue part, divided into two green parts, these green ones have to each be 5. Those two are 5, then this one is 5. Since then, this whole thing is 15. GK, entire segment, is 24. 24 minus 15 is going to leave us with 9 for this piece. Well, now we have to be able to answer these questions here. HI, that's one of the green ones, that's 5. IJ, one of the green ones, that's 5. GH, one of the green ones, that's 5. JK, we'll get that marked down there. IG, now IG is, oh, it's two of those green ones put together. Piece plus piece equals whole thing. That's got to be 10. IK is the 5 plus the 9 for 14. So oftentimes it helps to just label that whole picture first, and then you can answer all of those questions. Okay, so again, sometimes it's important for us to be able to take words and put them into pictures. You know, in algebra class, it was more about taking words and putting them into equations. Sometimes it's words, pictures. Oh, that word between, that means everything has to be all on the same line. Linear is implied when that word between is used. S has to be between D and P. So D and P must be the endpoints. S is somewhere in between, not necessarily right in the middle. Then write the segment addition. Well, the piece plus the piece equals the whole thing. Okay, the S plus SP, what happens to my equals DP. Okay, and then what happens is the same thing here. J is between H and K. H and K are our endpoints. We don't have to worry about scale. We need a diagram for relationships. So HJ is this piece. KH is the whole thing. And JK is the other piece, 3x plus 3. So now what happens is we use our geometry theorems to write an algebra equation. Piece plus piece equals whole thing. And that's going to be 5x plus 8 equals 48. Subtract 8 from both sides and divide both sides by 5. I found x. Now make sure you answer the question, solve for x, and find the length of each segment. Okay, so HJ is 2x plus 5, so 2 times 8 plus 5, 16 plus 5. JK is 3x plus 3, so 3 times 8, 24 plus 3 is 27. And notice those add up to 48, which is good because it told us our whole thing was 48. So make sure you answer all of the questions that are asked for in the directions. Okay? And it's not going to let me move on here. There we go. Again, M is between L and N. We don't need it for specific, just relationships. N is 4. That's the whole thing. Okay, so it's important here to like identify, is that a whole thing or that's the whole thing? Mn is 2.6. This is 2.6. So in order to find LM, we know the whole thing and we know the piece, we're going to subtract. LM is going to be the whole thing minus the piece that we know, which is 1.4. If you're given units, you should answer your question with units. Okay? So we've had, first section we have lines. They go on in both directions all the way infinitely. We've had line segment that has two distinct endpoints. And then we have a ray. It's going to have one distinct endpoint and one, it goes on in one direction. So if we're looking at this one, we're going to call that ray AB. Now it matters. We can't call it ray BA. So when we write it, it's got this notation with a single-ended arrow. It doesn't matter what direction this guy is going. If this is W and this is C, because C is the endpoint, when we name that guy, it's going to be CW. Start with the C. So you start with the fixed endpoint and go through. So the picture direction doesn't have to match the arrow direction. You never draw that arrow on the other side. It's always pointing to the right when you name that ray. Okay, and if you happen to have a line, you have to be a little bit careful here. This is point A and point B. I'm just going to do some highlighting things here. This would be ray AB. Ray BA would be that. Okay, so ray AB and ray BA are two different things in that picture, so just be super careful. Super careful with those. You might have ray AB, which would be this part, but different than that is ray BA, because that starts at B and goes through A on forever. Okay, so just, these are not the same. So getting used to looking at those. So, just some of that, again, the symbols and the words, if you have line AB, it's the whole line. A little bit of review on some things there. Line segment AB, that's just the line over the top with no arrows. Line segment AB, and that's got two distinct endpoints. Doesn't matter where these are, but ray AB has a fixed endpoint at A and goes through B. No notation at all on the top is the measure of line segment AB. Okay, so that's actually a number. That might be 4 inches. There's no figure for that because it's a measure. It's a number. Alright, I'm going to stop there for this video, and I'll pick it up here for the next part.